Our vehicle drives down the scene now, and when we press play, we have this nice tint to show us that we're in play mode, and we have our camera following, but right now, we still can't really control our vehicle. It just drives all the way down the road, just running all these obstacles over, pushing them off, and then eventually it gets to the end of the road, and then it just falls straight off. That's just because there's not an end there, but we need to be able to control this vehicle's movement. So first, we need to be able to move our vehicle so that it avoids the obstacles. If we open our player controller script, we're going to need a way to control our vehicle to move left or right. So we should probably just use a variable to do that, since we know it's probably pretty bad to just use a random number. So good to think ahead in general. We're going to make this a public variable so that we can control it just like we did with the speed. It will also be a float because we'll be using decimal points. And then we're just going to call it turn, lowercase t, capital S for speed. So you can see here turn speed has different capitalization. So this is a very standard, what is called a naming convention when you're programming. So for variables, we often use lowercase letters like speed, turn speed, even transform is a variable, to be able to very easily see when we're using a class or when we're using an object, when we're using methods, or when we're just using variables. Now we want to be able to move our vehicle left or right, so we'll do something similar to what we did with our transform.translate. Instead of a vector3 forward, we can actually use, there's a whole bunch of other options for vector3, so we can actually use like right. So this will move our vehicle in the right direction. Again, we're going to multiply by time.delta time, because we want to be able to update this position over time instead of once every frame. And then we multiply by that handy turn speed variable that we made before. So now in our game, if we take a look down at our game view and we select our vehicle so we can see the values, if we press play, nothing's happening. Well, that's actually because we're multiplying by a 0. So actually, if we click on turn speed and drag it to the right, it'll actually start turning right if it's positive. If we go to the left, it'll start going to the left because the value's negative. So easy way to see how we can move our vehicle left or right. Now that's great, but we'll need to be able to also control it as well. But first, what you're going to do in your player controller script, create your own turn speed variable. We'll make it public so we can play around with it in the editor. Make it a float because it will be a decimal value. And then in your update method, we're going to add another transform. This time we're translating with vector3 right. So we're using our right vector. And then our player can now drive down the road, and we can change the speed of its movement. We can even change the speed of its turn. However, if our player is actually playing the game, we don't want to be able to fly off the road, for one, but also, if our player is using like a joystick or something, we can't just be dragging this variable around. We can't do this for a single player, like it's magic behind the scenes. So we're going to create some actual magic so that the player can actually control their own movement. A very helpful thing to know before we get into programming this is understanding that Unity does a lot of things that make our lives a lot easier. So, in fact, if you go to the top left under Edit, or if you're on Mac under Unity, if you go down to Project Settings and you click on that, there's all these options for project settings, but what we really care about is actually our input. So this is actually our input manager in Unity, and they've helpfully already created a way where when you do something, it's already mapped to be able to change that value. So if you left click on the drop down on axes, you can see there's different ones, like there's actually fire button, so you can actually press like the left control button to fire something, or a second option, left alt, left shift. There's a jump, which is the space bar. You can take a look at all of these different options, but what we're looking for specifically are actually these horizontal and vertical axes. And so this is actually how Unity knows if we want it to go left or if we want it to go right. Using these horizontal axes, we can actually see those values change and how they change. You can see that there's inputs for the left arrow key to go negative or the right arrow key to go positive. There's also alternative buttons for using the A key to go negative or the D key to go positive, and it's called the horizontal axis. Knowing this, we can do something really easy to be able to control the player's movement. In our player controller class, first we're going to create a public variable so we can actually watch and see what it's doing. And this will be a float again, and we'll call this horizontal input because this is actually the input that we'll be tracking on our horizontal axis, left or right. And then what we need to do is we actually need to set this variable, which we'll do inside of our code. So we'll actually do this in our update method. So we use our horizontal input, we call our variable, and then we use the equal sign. So we're going to assign this variable some value. And now if you remember that input manager, so there's actually a class and a method that we can call just for that input manager. So if we type capital INPUT. So this is our input manager. It's called input. So now that we have our input manager class, if we type dot, and then we were looking for that axis before, so we can actually use our getAxis method. So this will give us the values for when we press the left or right key on that axis, but we also need to tell it which axis we want to use. And in this case, it's asking for the name of our axis, specifically a string. Now, a string is a way for your computer or program to create a word that is literally interpreted by the computer and easily understandable for us. So, for example, if I in here actually type in a double quote, you can see it actually auto-completes a double quote for me at the end. So this is creating a string literal inside of these quotes. So it'll literally interpret anything that I put in. I could literally say hello world, which is very helpful if I'm trying to, for example, print something, or I need the program to tell me an error that's happening or something like that. Using string literals can be helpful in that sense. For this, we actually type in the word horizontal because in Unity, in our input manager, the name of our horizontal axis is just horizontal. So now we're getting the input for whenever a player presses the left or right key. And then last but not least, we need to actually go into our translate and multiply this by our horizontal input. So now if you make sure you save, we can close out of our project settings. And let's make sure we select that vehicle so we can actually see what's happening on the horizontal input. Our turn speed is set to 0, so we know that's not going to work. So we'll set it to 1 for now. And then if we press play, so we should see if we press the left arrow key, it slowly moves to the left. If we press the right key, it slowly moves to the right. And we can use the A key too if we want to use the other key. It'll move to the left. If we use our D key, it will slowly move to the right. So we know our input manager is a very handy way of understanding. So we know our input manager is working. You can even see the values change from -1 to +1. Key is a very handy negative. Another public float variable input manager. Translate by our public as well. So we can see it. Forward input. So now in Unity, if we close the project settings and then we press play, we should see hopefully our vehicle doesn't move at all. Cool. And then if I press the forward arrow, it moves forward. If I press the backwards arrow, it moves backwards. Same thing with W, moves forwards. S moves backwards. Our players full control from their joysticks to know when they're to different translate where we are moving. We have full control over our vehicle now. It's not just driving off down the road. But now we have some weird stuff happening. So when we press the left arrow key, we slide to the left. And if we press the right arrow key, we slide to the right. To visualize again what we're trying to do, I'm going to go, mouse is hovering over the scene. The Y rotation is actually on, and changing actually when we click on this circle here. If we drag it to the left, you can see in the inspector underneath transform, the Y rotation is actually the thing that's moving. So that's probably what we'll want to change in our code. In our player controller class, we already have this bit of code here where we're moving left or right. Let's see, well, if we are using our vehicle's transform, then we'll need that transform component. Now let's see, luckily, because my IDE suggests different methods that I can use, well, there's this one method called rotate, so it'll actually rotate it at an angle. Well, let's just see what it does. So if I click on the rotate method, and then I type an open parentheses, it suggests different things. So it wants a vector 3, Eulers, an axis, and a float angle. That one seems pretty useful. Well, we know that the axis is that y-axis, that vector 3 up. So actually, vector 3 dot up. And then it wants the angle. Well, we kind of already calculate an angle here because of our turn speed. Let's just see what it does. So if we select our time, if that was what we'll play again. There you go. Now it looks like our car is really driving down the road. Thing to note. So in fact, if I actually go in my scene view, and I'm going to keep play on here just so we can kind of see what's happening. So you can see in our game, as I move forward, it always knows what direction it's moving forward. Now, we've been moving all of our objects in our scene, if we select our move tool, based on the global position of things. So we're always doing it based on 0, 0. Our Z arrow will always go positive in the Z. Same thing with our X arrow and our Y arrow. But at the top left, next to all of our tools, you'll notice this button here that says global. In fact, if we actually click on global, we can set this to local. Now, let me get a better angle so you can kind of see what's happening. So as I turn the vehicle, make sure you have the game selected. As I turn the vehicle, you can see that the Z is changing, and it's always pointing in that forward direction. But then, if I switch this toggle back to global, you can see that the Z flips back to our world. So when you're trying to position, so that's very important. We need the speed and the speed, so that way when you're pressing play, now it's your turn. Now our game looks really good. Our player has full control. We got rid of our folders. We have our script. So we can actually take it. If I click off of it, underneath that empty object, our player controller script. So we can even add a variable, a reference in our script in Unity. So if we actually turn this to private, we won't have that reference anymore, and we'd actually break our camera. So what you're gave this variable a reference in our script in Unity. So if we actually turn this to private, we won't have that reference anymore, and we'd actually break our camera. So what you're going to do is in your inside the inspector game object, going We finished off all of the functionality of our game now, so our player has full control over this vehicle. When we press the up arrow key, the vehicle drives forward. If we press the right arrow key, we turn right. If we press the left arrow key, we turn left. We can even press the down arrow key to go in reverse. So now we have a lot of amazing control. We learned a little bit about empty game objects so that we can use it to keep our projects organized, like in our environment game object, storing all of our different environment assets, or our obstacle game object, keeping track of all of our different obstacles in our scene. We also learned, and then we learned of just translate and horizontal input. And then we learned about a new method that we could use. In this case, our transform dot instead of just from absolutely nothing to creating our to program. Feel super proud of yourselves for making it all the way to the end of the road. And we'll see you in the next project. Welcome to your very first challenge. In these challenges, you'll be given a new project, but it will be filled with bugs that you'll have to fix and missing features that you'll have to implement. The goal here is to take the skills you learned in the unit and put them to the test. It flies to fix and missing features that you'll have to implement. The goal here is to take the skills you learned in the unit and put them to the test in a different environment. For example, in the first unit, you learned to program a car that could drive down a road. In this challenge, though, you're not going to program a car, you'll program a plane. And this plane is going to come with all kinds of issues. It flies backwards instead of forwards, you can't steer it, and it goes like 1,000,000 miles an hour in charge. If you think of a car. In addition to the main challenges, so just a bit of, you may be tempted to happen issues and work through these to the other side. So to make all that nicely down, welcome to challenge 1. Now, if you remember in our first project that we made, we added a lot of functionality to our project with this vehicle that can drive forward and these boxes that have physics and collisions in it, and we can fully control this vehicle, turning it left and right, driving it forwards, driving it backwards. So, for our first challenge, you can see that we have this plane flying game, and if I use the arrow keys, I can control it going up and down. Our plane is flying forwards at a nice, consistent speed. We have our camera over on this nice side view so we can see our plane flying around and we can fly through all these obstacles, and we're following the plane really nicely. Okay. So we can nicely. Oh my gosh. The plane just flew straight backwards. It's like, it just keeps going incredibly fast. That's far too fast for us to be able to do anything. Oh my gosh, just flying straight up all the way directly into the air. Well, that's not good. Can I even control this? No. That's really frustrating. For some reason, our camera also has this weird front view, and it doesn't even look like we're following the plane at all. I don't even know where the plane is. It's gone. That's frustrating. Okay. Now, on our challenge page, below the video, you can see that there's all of these different steps that we can go through to make our project complete. You can see here listed the entire step that you have to do. So the problem is the plane is going backwards. We need to make something. You can mark it as incomplete so you can keep track. Use the internet. There are so many different resources that you the document if I outcome that we made. They have that at Welcome to your very first lab session, where you will begin working on your own personal projects. Unlike the prototypes, where we are working on the same type of project together, in these labs, you'll be working on your own project, which will be completely different from mine. You have the great power of coming up with a unique concept for your project. But as you know, with great power comes great responsibility. You are responsible for making sure you actually finish it. You need to take the time to think through your idea and plan out how you'll get it done. So by the end of this lesson, you will have completed a design document for your project, including an outline of the concept and timeline for completing it. Here's the tricky thing about coming up with a concept for your project. On one hand, you want it to be unique and amazing and like nothing the world has ever seen. On the other hand, you want it to be complete and functional and playable. You want all of these things, but unfortunately, they're kind of at odds. Now, don't get me wrong, it is possible to create a unique, amazing project like nothing the world has ever seen that is also complete, functional, and playable, but it would just take a lot of time. And I don't mean hours or days, I mean years. And maybe not just years of your life, years of other people's lives. To make some of the console games you might have played before, it can literally take hundreds of people, thousands of hours, which means we're talking about hundreds of thousands of human hours to make some of these products. So given that, the trick here is figuring out how much time you have to dedicate to this project, then striking a balance between uniqueness and completeness to get the best possible outcome. Here are 2 tips for how you can do that. First, in this course, as you create different prototypes, you'll learn how to program a ton of awesome different features. So why not build on those features that you'll already know how to program instead of having to figure out everything from scratch? The second thing we'll do to make sure we actually complete what we set out to do is not try to make a full-featured, production-ready, highly polished project. Instead, our goal will be to make a minimum viable product, or MVP. A minimum viable product is a version of your project that has enough features and looks good enough to satisfy early users, allowing you to get feedback for future development. So in completing this design document, recognize your time constraints, build on the features you have, and aim for an amazing minimum viable product. Now let's start creating. Welcome to the lab, where you'll be working on your personal project. Now, personal projects are designed for you to work on your own with less instruction. So it's a chance to create a project that you really care about and can be really creative with to make whatever you want. They're a great opportunity to apply and solidify the skills that you learned in the lessons and in the challenges. Let's take a look at my personal project. So we've created this endless running game where we have a deer being chased by different animals and obstacles like rocks. Our screen scrolls endlessly, and the whole objective is to last as long as possible, collecting different hearts and trying to stay alive. And then we can even restart our game to try again. Now, these personal projects are designed to be built on top of all of the different things that you learned from each individual unit and each individual challenge. Consider Prototype 1, where we learned how to create our first project, and we really get to learn a lot about player input that we then apply into our challenge. And so we can have our player move this vehicle around using the arrow keys to turn and to move forwards and backwards. In our second prototype, we'll get to learn about the basic gameplay to be able to create all of these animals that spawn down the scene. We even get to learn about how we can spawn obstacles and projectiles based on the player's input, and learning a little bit about collisions along the way. In our third prototype, we take our projects a little bit further using sound effects and animations to make our games really cool. Look at that jumping animation. This farmer's so excited, running through the forest, and then we can collide with these different obstacles, create this huge puff of smoke. In our fourth prototype, we'll get to learn about the different gameplay mechanics, the power-ups, increasing difficulty, so we need to avoid these enemy spheres coming at us and stay alive. Get these power-ups so that we can bump them away if we need to, and then eventually make the power-up go away, until finally we can bring all of these different parts together to be able to make a full game with really cool effects, with nice user interface, to be able to set difficulty states, interact with different objects, accumulate score, and even lose the game. Now, the goal of our personal projects is all focused on two things: the completeness of our game, so how much of what we actually completed is what we intended to finish, and then the creative or applicable ways that we made our game. So how much new things did we learn or add to our game to either work really well or look really nice? And then did we apply the skills that we learned to be able to make something that's our own? Now, these two things are always in constant balance of each other, and so at some point you have to decide when your game is exactly what you wanted it to be, but also, is it good enough to share with other people? So taking a look at what I set out to do with my own personal project, I have this handy design document that helps to outline the different minimal things that I'm trying to complete, known as a minimum viable product. Now, at the end of the day, my game definitely could use a lot more work, but to see where we started off with, I wanted to create a game where the player could control a deer in a top-down style game using the arrow keys to move the player in a bunch of directions around the screen. For my gameplay, I wanted animals and obstacles to appear from the top of the screen, and the goal of the game was to avoid crashing into the different rocks or being eaten by foxes and getting bit. For the sound and effects, I wanted sound effects to happen when I bumped into other animals, if I crashed into a rock, or if I got bitten by a fox. For the particle effects, I wanted them to pop up whenever I crashed into a rock. And then I wanted to hopefully get a scrolling background to make it look like all the animals are running really quickly. For the gameplay and the mechanics of my game, I wanted the game to progress whenever waves of foxes bit the player and attempted to attack, so that it made the game a bit more difficult to stay alive. I also wanted to put in hearts that appeared so that the player could regain their health back. In terms of what I wanted the user to experience, I wanted their lives to decrease whenever they were hit by a rock or bitten by a fox. And then at the start of the game, we'd have our "Oh dear" title screen that would appear, and our game would end when the player ran out of lives. There's even other additional features, which is the point where you can kind of stretch your ideas and your imagination to see what you can do. And so some features that I wanted to add so people would bounce off of larger animals, making it harder to control the player and avoid all the obstacles that are in our game. Now, with this minimum viable product that I wanted to complete, in the design document that we provide, there will be a timeline to help outline the things that you want to accomplish every day, every week, with the different features that you want to add to your game. So you can see in my outline, I wanted to set up my camera, and then I wanted to move the player, and then I wanted objects to spawn randomly. I added in some collisions. Eventually, I moved away from just having these primitive spheres and cubes on the scene, and I replaced them with some actual assets that I could use to make my game feel a little bit cooler. After that, I added in some of the different gameplay pieces like health and game over. After that, I polished my game up a little bit more, adding in some of those particle and sound effects, that scrolling background, and that music. And then if I was able to, I would add in different power-up objects to make the player jump or to save the high scores of all my different players. So you're trying to get to a point with your project where your game will have just enough to be fun and be enjoyable, but also give you opportunities to get feedback from other people, like your friends or your family, your teachers, your classmates, so that you can further develop this cool little project you've made and make it even better. At the end of the day, you're not trying to create the best or the flashiest project, you're just trying to make something that works really well and feels really nice to the people playing it. Now, one major thing to note for this project, there will be a lot of temptation to really go above and beyond with this project, make it look incredibly amazing, but that takes a lot of time and a lot of energy to be able to do. So don't go and try and make the biggest or the best game out of your different projects, because for now, this is just the first project. So try and stick to what you're learning, apply what you've learned in this project, and develop something that you can feel proud about at the end of the day. The only real limitation with this project is the amount of time that you have, and with enough time you could make an absolutely amazing game, but with the short amount of time that you have to create this project, make it as good as possible with the time that you have, and walk away from it feeling proud. With that, we'll move on to the next step. Now we have an idea of what we're going to accomplish with our personal project, and now I'm going to walk you through some of the tools that we have that highlights all over the we're going to accomplish with our personal project. And now I'm going to walk you through some of the tools that we have so that you can turn your idea into a reality. So I went over the example design document before of the project that I made myself that highlights all of the different aspects of my project.
Now, you can find a link to the example design document below this video.
And now you can see in the design document that I downloaded, it has all of this different information that I can use to figure out what information I need to create my game. Different things like the perspective of my player control, user input, the goal of the game, special effects and animation, additional gameplay mechanics. So this design document is very helpful as we structure our game throughout this process. In fact, one of the best ways that we can use this design document, and especially the project concept section, is by using this to actually break down the different mechanics of other games that we play. So whether it's a game you play on your phone or a game that you play on your console or computer, this can be a really great way that we can actually take a look at some other games that people have made, break down the ways that they've created their game to get an idea of how we actually want to create our game ourselves. It's particularly useful that this document enables us to break out the different aspects of player control, the basic gameplay, the sound and effects, the actual mechanics of our game, the user interface, and any other additional features that were added to a game afterwards. So the easiest way that we can use this document for right now is by taking a look at different examples. Let's take a look at this UFO game, for example. So if we look at the player control, we have another top-down style game our player can move with the arrow keys. You can actually charge a beam and activate it to pick up all of these cows. It looks like in the game we have the cows that we're trying to pick up. We have these helicopters that we're trying to avoid. And the goal is to pick up as many cows as possible without getting hit by one of the helicopters. For the sound and effects, you can hear the cows moo when they're picked up. You can hear the blip sounds happening from the helicopters. Fire or projectile. There's a sound for when we click to pick up the cows. There's even some cool background music. Our game scrolls. And then as our game progresses, we're constantly trying to avoid all of these different helicopters to get the high score. Until we get hit by a helicopter and the game ends. If we take a look at the UI, so there's no health or anything, but there definitely is a score. We get this game over text and we can restart our game. You can see that the game tells us our objective. And I believe when we use our beam, it actually tells us to recharge. So in this design document, we control a UFO in this top-down game where arrows and mouse clicks make the player move and interact with other objects in the game. During the game, cows and helicopters appear from the top of the screen, and the goal of the game is to pick up as many cows as possible to gain score while avoiding helicopters. There are sound effects when a cow is picked up, a beam is activated, or a helicopter fires a projectile. There are particle effects when the UFO is hit and when the beam is activated. There will also be background music. And then as the game progresses, more cows and helicopters spawn, making it difficult to collect more cows. For the UI, the score will increase whenever a cow is picked up or a helicopter is hit by a beam. At the start of the game, the title doesn't appear, and the game ends when a helicopter hits the player. And then for other, there's the ability to restart the game and a way to tell the player when the beam is recharging. So hopefully that little sample game gives you a good idea of what you're trying to accomplish. I would highly recommend taking a look at some of your favorite games, seeing what some of the really basic mechanics and controls are of that game. See if you can break it down yourself. Take a look at other games. Go watch videos online, reviewing other games and their play styles and mechanics, and see what you can learn as you try to figure out your own project that you're trying to develop. So take a look at your blank design document, go review other games, and we'll see you in the next step. And tools that we can So we've taken a look at some examples that we can use to fill out our design document. And now we're going to try and fill out our project concept itself. So what I'm going to do first is I'm just going to enter in my name and today's date. And then we're going to start filling in the blanks for the concept of our project. So for this project, I want to create an interesting game where the player doesn't actually control anything. It's kind of like a tap or a click based game, so you control the mouse, really, not even a player type. And then in this will be a side view game because you want to be able to see the things moving up and down the screen. And then for user input, I'm just going to do everything actually just on clicks. So where mouse clicks makes the player destroy different objects. So I'm imagining maybe there's something like crates flying up in the sky. So for basic gameplay during the game, we'll say some crates, and then maybe like a bad item appear from the bottom of the screen flying upwards. And the goal of the game is to get a high score while not missing any of the crates. Let's see, and then for some sound effects, it would definitely be really cool to have sound effects when you click a good or bad object. And then for particle effects, small particle explosions when the objects break. And then for the optional, we'll see maybe eventually there will also be background music that we can add to our game. So maybe that'll make our games just feel a little bit cooler, more fun. For the gameplay mechanics, as the game progresses, we can make it so that more and more objects spawn over time. So that makes it difficult to track all of the objects we should be clicking. And then optionally, let's see, what's a fun optional mechanic? Maybe we start introducing more and more different objects from the standard that can act as power-ups. And a fun thing would be we can add combos. So the more that we click in a chain, the more points we can earn. For the user interface, we'll definitely have a score we're keeping track of that will increase and decrease whenever the player clicks on a good or bad object. And then the name of this game, we'll call it Clicky Crates. And the game will end when we miss one of the good objects. And then for other features, we can restart the game and we can have the player set the difficulty. So that sounds like a pretty interesting idea that we can try and tackle. In general, a really good thing as we're creating this game. Think of how cool it could be, but keep in mind we're going to be starting very simple just to get those interactions in. So you can use different models or assets from the asset store, for example, to get a better idea of the game that you're trying to create. But at the end of the day, try to keep the gameplay as simple as possible, so then we can add in whatever different models or assets we want to use for the different objects in our game later. So eventually maybe these crates could be something different, could be like animals that we're trying to catch or something like that. Another good tip is that this is a good opportunity to catch yourself if you're being really ambitious. One of the good signs of that is if you're filling out a lot of information for each of these different boxes, that's probably a good sign that you're taking the project a little bit too far. That'll be a really big problem when we get to the next section of filling out our timeline, because there's only so much time that we'll have to create these different projects. So you want to make sure that you try and keep this project to as simple and precise as possible, and just try and focus on making it a fun and enjoyable experience that you can learn from. Another thing too is that these could all just be guesses. This could change my user interface. Maybe instead of having a score, I'll have a timer instead, or something like that. Maybe I'll even add in like indicators for where those objects are coming from. Who knows? Maybe I'll not use sound effects and I'll just use something else. These things could all change depending on as I create my project, as I test it out and put it in front of other people. It could change over time. That's totally okay. That's kind of the goal of what we're creating. It will be something that might look a little different by the end of it just because of different input that we've gotten from our friends or family, classmates, or teachers. A really good first step to kind of see what people think of this idea that you have is after you've completed your project concept, go bring it to one of those people. Bring it to a family member or one of your friends. Talk about your in or improve and what your design document. Make sure you, hopefully after doing some feedback, see if the idea that you have makes sense and see if there's room to improve. Now it's your turn.